Welcome to this course. So we are going to be discussing about stack and how we can actually implement that using Python. So the first thing I'm going to do is that I'm going to use this diagram that we can see right here to explain the stack. So in this diagram we have two rows. So each of these rows has their own column. So we can see the first row, we can see we have 5 columns, and in the second row also we have 5 columns. So in the first row, column 1, let's assume that in the list of the in our list we have item 1 already. So we can see that right here, denoted by this rectangle that we can see right here. So we have an item 1, and what we are trying to do now is that we want to push item 2 into the list. So when we get to the second column, so we can already see that now we have 1 and 2, which means we have 2 items already in the list, or we can say we have this item already being pushed into the stack. And here we can see the item 3 is coming. So we want to push that item 3 into the list. And when we get to the third column, so we can see that the item 3 is being pushed into the list, and the next thing we are doing is that we are pushing the item 4 into the list, and so on. So we can see we actually did the same for the column 4 and column 5. So which means that at column 5 we have item 6 pushed into the list. So now when we get to the second row, column 6, so we can see what we are doing here. We are performing an operation, and we are using the pop method to pop out the items that we have in the list in the stack. So we can see that right here. So also here we can see we continue to do the pop. So we also pop 6 out, we pop 5. And when we get to the column 10, we also pop out item 2. So which means at the moment we only have one item left. So if you notice from the first row, you will notice that we also started with the first item. So we still have that item left in the list. So now we already pop 2, 3, 4, 5, 6 out of the stack. So what is stock? The stock data type is a collection of items where items are added to and removed from the end called the top. So the end of the stack is what we call the top, and the end opposite the top is known as the base. So stacks are ordered LIFO, which means the stack operation are given in last in, first out. So that means the item that comes in last is the one that comes out first. And the base of the stack is significant since items stored in the stack are closer to the base, represent those that have been in the stack the longest. So the most recently added item is the one that is in the position to be removed first. So when you add an item recently, so as we can see from the diagram, is the one that is in the position to be removed first. So when we had 6, which is the last item we added here, so we can see that 6 is in the first position to be removed first. And we can see that the ordering principle is something called the LIFO, which I already mentioned. And that means that the last thing is the first out. So the last item that we added, which is the 6, is the first item that is coming out first. So which means that stack provides an ordering based on length of time in the collection. So near items are near the top. So when we talked about the new item, for example, we can see 5 and 6. These are the most newest item, and they are near the top. So we can see them at the top, right? Why other items are near the base? So we can see the older item. So 1 is the oldest, so it's coming from here, and 2 follows. So they are near the base, and so on. So for example, everything that I talked about, we can see it from this diagram. So today we are going to learn how we can actually implement everything that we are seeing on diagram using the code. So let's get started. We will continue with the lecture. So here you can see I already have some points added to this Python. So the first one is the push method, and the push method has a new item to the top of the stack. So the second one is the pop. It removes item from the top of the stack. And the third one is the pick. It returns the top item from the stack of the stack. And we have the fourth one, which is the empty. It tests to see whether the stack is empty. Then we have the size. It returns the number of items on the stack. So I added those points for you to see what we are trying to do here. So when we start writing out the stack class, so we start with a class stack, and it's going to have the object. So it will enrich the object. So the next thing we want to do is to have a method, which is going to be the init method. And the init method is going to take in self. So we can see that since it's an instance method. So right here, we are going to have the underscore underscore also. And after that line, we want to check if self dot items, so is equal to something. So initially, the item is set to an empty list. You can see that right here. And after that point, we want to have a method which is going to check if the item is truly empty. So as we can see that we don't have any item at the moment. So let's check if this is going to be true. So return self.items. So we want to check is equal to empty. If it is true, then we are expecting to see true. So let's see that. So I'm going to create an instance of the stock. So when I create the instance of the stock, so the next thing I want to do is to basically check if the stock is empty. And the way I'm going to do that is to grab the instance and call the method is empty on that. So we can see that right here. So we call that method on that, and we can try to print and see what happens, right? So as a matter of fact, if I print now, I won't get any results. So here you can see we print, but nothing is coming out. And the reason is because we needed to print this particular object. So I'm going to wrap that with a print. And right here, I'm going to wrap this. So let's print again and see what we have. So we can see we have true right here because at the moment we don't have anything in the item. So let's take a look at the diagram again. So initially we want to push something now to the item. So let's say we want to push one first of all. So and what I'm going to do is that I will create a method which is going to be the push method, which is going to allow us to do just that. So we are going to say def push method. So my push method is going to allow me to add an item. So definitely it's going to take in an item as a parameter. And the next line of code is going to give the action to this push method. So what this push method is going to do. So this is what the next line of code is going to do. And what we want to do is to basically push an item to the item list. So here initially we have it to be empty. So now we want to append to that. So which means that we are adding an item. So I'm going to use the parameter that I have here, which is the item. So that is going to be added to the items. And now we can check quickly if we have something added to the store. So we can use the s dot push. So let's say we want to push the first item to be 1. So when we push the first item to be 1, then we call the isEmpty method. Then basically we should see that this one is going to change to false, the one we have right here that I just highlighted here. So because we are pushing an item, so our list is going to contain one item. So let's push that and see what we get here. So we push, immediately we can see we have this to be fast because we have an item in the list. Now let's try to think of how we can also add a pop method. So if I had a pop method, so what the pop method is going to do is to just allow me to remove the item which I just added, for example. So here I'm going to use the pop. So the pop takes in no parameter. So what it's going to do is that it's going to return the self dot items. In that case, we want to pop that item from there. So we have a built-in pop method which we can use for that. So here we can see we have this code which is going to perform that action. So now let's come down and let's check if we can actually pop something out. So I'm going to say pop. So what I want to pop now is that I want to pop one which I just added. Basically, I can use a print statement for this so that we can see if this one is actually being popped out or not. So now if we check by popping and we try to call this empty method, then so we pop one, so we can see that right here. So we pop one and immediately it's empty change back to true because at the moment we don't have anything in the stock. We pushed and we popped that immediately. So let's try to add more push into the stock. So for example, we can see from the diagram that we push one, we push two, we push three, we push four, we push up to six, and we can continue pushing, right? So push, 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 push. So this should be up to 1, 2, 3, 4, 5, 6. So now we have 6. So what I'm going to do is to push 2, push 3, push 4, push 5, push 6. So we want to push 6 items into the stack. So if I run this code now, we have item being pushed at the moment to the stock, so up to 6, and we pop 6 out immediately. This is why we can see the 6 is coming. But what I'm going to do is to comment this line out for now, and let's try to push back again. So here we can see we have is empty to be set to false because we have 6 items in the stock already. So what we can do next is to check what item is at the top of the stack. So what I'm going to do is to use the pick method for that. And how do we check this? So one thing that people used to make mistake of is by saying pick has the self, which is going to be the instance method, and they immediately return what we know as the self dot items into the index of 0. So this is wrong. This is not returning the top item from the stack, since stack is what we refer to as LIFO, which means last in, first out. So you need to get the last element in the stack. So you need to return the last element in the stack in this case. So and the way we are going to do that is by using the length, which is the len of the all items that we have. So dot item. So in this case, we want to go with -1 since our index starts with 0. So we want to go with -1 here. And right after here, we can make use of this pick method to see which of the item is at the top of the stack. So one thing that we should also remember is that the end of the stack is called the top. So the end of the stack, so right here, is what we call the top. The reason is because these stacks are ordered LIFO, which means the last 10. This one is the last 10, is the first out. So for now, what I'm going to do is to use this method to print out what we have at the peak. So, and we can basically copy this line of code instead of typing. And right here, let's put that here. And here, we are going to change this to peak. So changing this to peak, here we can try to see what we have at the moment. So I'm going to run this. So the expected result should be 6. So let's take a look. So we can see we have 6 right here. So because this is the one that is at the top at the moment and we are returning that. So one thing you should notice is that this is not popping out. This item is only showing to you what you have at the top of the stack, and this is 6 at the moment. So if we push another item in, then what we have at the top of the stack is going to change. So let's say we have 7. And right here, we can see that what we have at the top of the stack is 7 now. So this is the point. If you push 20 right here, so what you have at the top of the stack is going to be 20. So we can see that right here. So if you want to pop out what we have now, so we can use the pop method. So if we pop that out, we can see we have 20 at the top and we pop that 20 out. So since we pop 20 out now, let's try to print the peak method again and see what we have presently at the top of the stack. So what we are going to be expecting is 6, right? So I'm going to run that and we can see we have 20 peaked, which is the initial one. We pop that out and immediately we have 6 at the top of the stack. And this stack is still not empty, as we can see, because we still have these items up to 1. So this is the whole point about the stack. The next thing we would like to do basically is to check the size of the stack. So here we can see we have size returns the number of items on the stack. So, and in order to do that, we can just define a method which is going to be size. And this method is going to take itself and basically it returns the length of the items that we have in the stacks. So here is going to be self.items and that gives us the size of the stack. And in order to check that, we can also use the print method for that. So I will Control C, and don't forget we already pop out one item. So in this case, we should be expecting something like 1, 2, 3, 4, 5, 6, 6. So initially it was 7. So let's check if that is correct. And what I'm going to do is to come right after here and put that right here. So what I want to check is the size of the stack. So if I run that, so here we can see we have 6. So the item, the length of the stack now is 6. Let's change this so that we are not getting confused of what we are doing. So if we run that, so we can see the peak at the moment is 8 and the size of the stack is 6 and this stack is still not empty. So this is the point about the stack. I hope you find it helpful. Thank you for watching.